Am I audible? Hello? Basuraj? Basuraj D. Am I audible?
Sir,
Akhil Afroos? Basuraj Shakarappa Chetty? Am I audible? Okay. Now am I audible? Basuraj?
yes, sir.
Now, when we were discussing about the Butterworth filter yesterday, I was telling you that the magnitude function of a Butterworth filter is given by 1 divided by 1 plus omega by omega c to the power of n is 4 to the power of 1. Okay? So this equation is called as magnitude function of the Butterworth filter. Magnitude function of the Butterworth filter. Here the magnitude h of j omega depends upon three values, namely omega, omega c and n. So if omega c is fixed, then it depends upon two values only, omega and n. What is n? It is nothing but the order of the filter. N is the order of the filter. And omega is the frequency. That means if the order is fixed, the cutoff frequency is also fixed. Then omega decides the value of h of j. Okay? The value of h of j omega is dependent upon the value of omega, provided n and omega c are fixed. So we also sketched the magnitude response curve yesterday. So magnitude of omega take along vertical axis and the frequency omega along the horizontal axis. For an ideal figure, that means up to the particular frequency, the magnitude should remain 1. Magnitude means output by input, V naught by Dr, that should be 1. And above that cutoff frequency, suddenly it should become 0. This is the characteristics or behavior of an ideal filter. But for a practical situation, the magnitude does not remain constant. It keeps varying, it keeps decreasing. So, this is the shape what we expect in a Butterworth. Okay? This magnitude characteristics is defined by this magnitude characteristics is decided by this power, this equation. So this magnitude function varies with respect to the frequency. महबूब ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಅಭಿಷೇಕ್ ಮಿಸ್ಟರ್ ಅಭಿಷೇಕ್
Yes, sir.
Now h of j omega is equal to 1 by 1 plus omega over omega c plus over 2 over 1 by 2. Like this. That means for a particular order, particular value of n, this is the characteristic. If I choose a different n value, okay, then I get curve like this. Another n value, we get curve like this. Okay. So this is where, for example, n equal to 2. This curve is saying, for example, n equal to 5. This curve is saying n equal to 5. It means we conclude that with increase in the order of the filter, it approaches to the behavior of an ideal filter. So this is the ideal filter. So with n is equal to 10, okay, the behavior is almost approaching to that of an ideal filter. So higher the order, better would be the response. But we find that all the magnitude curves are crossing here. So it crosses here and proceeds like this. Then it crosses here and proceeds like this. Everything is crossing. This frequency, at which all of them are crossing, and their magnitude here is 0.7. This is an interesting fact one can notice in Butterworth filter. We find that when they are crossing here, the magnitude is 0.707. Whereas at origin its value was 1. But here where they are crossing, the magnitude becomes 0.707. That means the magnitude is decreasing from 1 to 0.707 at this frequency. This frequency is called as the cutoff frequency. Okay? So what are the observations we make? Omega equal to 0. Magnitude of omega is 1 for all filters of any order. So for filters of any order, at omega equal to 0, the magnitude is 1. And then at omega is equal to omega c, magnitude of h of j omega is equal to 1 by root 2 or that is equal to 0.707 for all filters. And as omega approaches infinity, the magnitude of h of j omega it approaches. So these are the three things we can notice here. At omega equal to 0 is 1. At omega equal to omega c is 1 by root 2 or 0.707. And then when the frequency approaches to infinity, the magnitude also approaches to 0. The magnitude approaches to 0.
Sorry, your voice is not clear, sir.
Suppose if we select omega c such that omega c value is 1 radians per second, then that is called as normalized filter. What is a normalized filter? Normalized filter is one in which the cutoff frequency omega c is 1. Okay. For normalized filters, omega c is equal to 1. For the normalized filters, omega c is equal to 1. So with this, then magnitude of h of j omega is equal to 1 by 1 plus omega, because omega c value we select constant, to the power of 2. This whole to the power, we want simply replace this with 1. Now let us square on both the sides. Squaring on both the sides. Magnitude of h of j is equal to 1 divided by 1 plus omega power 2n. Because I have 1 by 2, so when I square this one, so this becomes simply 1 plus omega to the power 2n. See, h of j omega is a complex quantity. H of j omega is a complex quantity. Therefore, it can be written as h of j omega into h of minus omega. Okay? So this is equal to 1 divided by 1 plus omega. Okay? We have seen already, suppose x is a complex quantity. Okay? X conjugate is x conjugate. Product of x into x conjugate. Okay? X conjugate is equal to magnitude of x square. This we have already seen in many cases. Okay? If h of j omega is a complex quantity, its conjugate will be h of minus j omega because we are replacing j with minus j. Okay, wherever j is there, that we are replacing with minus j. So we are multiplying two such quantities. Suppose h of j omega is x, h of minus j omega is going to be x conjugate. Product of x into x conjugate is nothing but magnitude of x whole square. This we have seen earlier. So in the same fashion I'm writing, this is the magnitude of h of j omega whole square. This can be written as product of h of j omega into h of j.
Sir.
Hello, tell me.
Sir, yeah.
Sir.
Sir, voice is not.
Voice is not audible.
It's audible,
No,
sir,
sir.
but not clear.
No, sir, your voice is not audible, sir. It's echoing, sir.
Okay. Now is it okay? Now is it okay? Is it audible now? Anyone can respond, please.
No, sir.
Is it audible now? Is it audible now?
Sir,
Yes, sir.
it's not audible, sir. It's echoing, sir. Your voice.
Echo is there. Right? Please tell me now. How about now? What? How about now? Is it audible?
Yes, sir.
Yes, sir.
How about now?
No, sir. It's echoing, sir.
It is echoing.
Yes, sir. Sir, before this you wore a headphone, no, sir. It was clear, sir.
Now you please tell me, is that okay?
Yes, sir.
Yes, sir. It's okay, sir.
Is it audible now?
Yes, sir.
Is it audible now?
Yes, sir. It's audible, sir.
ಸ್ವಲ್ಪ ಮೈಕ್ರೋಫೋನ್ ಪ್ರಾಬ್ಲಮ್. ಈಗ ಇದನ್ನ ಇದು ಹಾಕಿದಾಗ ಎಪ್ಪು ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ತಲ್ಲ, ಈಗ ಇದು ಈಗ ತೆಗೆದ್ಮೇಲೆ ನೀನು ಕ್ಲಾಸಿಗೆ ಆನ್ ಮಾಡಿ.
Sir, your mic is muted, sir.
Connected ಅಂತ
ಕೇಳುತ್ತೆ ಸರ್. ಹಲೋ ಹಲೋ ಕೇಳುತ್ತೆ ಸರ್. ನೋಡಿದೆ ಸರ್.
Is there any problem now? Yeah. Is it audible now? ಕೇಳಿಸುತ್ತಾ ಮೈಕ್ರೋಫೋನ್?
ಹಾಂ ಸರ್.
ಕೇಳಿಸೋದಾ?
ಅಂದರೆ ಎಕೋ ಬರ್ತಾ ಇದೆ ಸರ್.
ಎಕೋ ಬರ್ತಾ ಇದೆ. ಫ್ಯಾನ್ ತೆಗಿ.
ಇವಾಗ ಸರ್ ಪರವಾಗಿಲ್ಲ ಸರ್. ಈಗ ವಿಂಡೋ ತೆಗಿಲ್ಲ ಸರ್.
ಆಕ್ಚುಲಿ ಇದು ಮೀನಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತಿಲ್ಲ. ಅಭಿಷೇಕ್, ಮಿಸ್ಟರ್ ಅಭಿಷೇಕ್.
Yes, sir. Yes, sir.
Is it audible now?
Yes, sir, but not clearly, sir.
Not clearly.
Sir, echo. I am hearing echo.
ಓಕೆ, ಬಟ್ ಮೇಬು ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ, ನನಗೆ ಇದ್ರಾಗ ಸೌಂಡ್ ಬರಬೇಕು, ಇದ್ರಾಗ ನಂಗೆ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ, ಇದ್ರಾಗ ಸ್ಪೀಕರ್ ನನಗೆ ಈ ಸ್ಪೀಕರ್ನಾಗ ಕೇಳಿಸ್ತದೆ, ನನಗೆ ಹೆಡ್ಫೋನಾಗ ಕೇಳಬೇಕು.
ಅಂದರೆ ಜಸ್ಟ್ ಮೈಕ್ ಬಂದೇ ಆ್ಯಕ್ಟಿವ್ ಆಗಿದೆ ಸರ್. ಇದೇ ಆ್ಯಕ್ಟಿವ್ ಆಗಿದೆ ಸರ್.
Is it audible? Okay. So I think it's audible now. Is that okay?
Yes, sir.
Is that okay now?
Yes, sir.
But is there echo still now?
No, sir.
I think I will manage with this. Okay, we will continue with this. Okay. Camera on. Okay. Why now, we have seen earlier, product of x into x conjugate, is x square. That's what I have done.
Sir,
Now let us
video.
replace s equal to j omega in this equation. That means wherever j omega is there, that I will replace with s. With that, h of j omega can be written as h of s. h of minus j omega can be written as h of minus s. And here I have omega. What is omega? Omega is equal to s by j. S equal to j omega or omega is equal to s by j. Okay. Now h of s into h of minus s is equal to 1 divided by 1 plus s by j to the power. Okay. So j omega I replace with this. Minus j omega I replace with minus s. Then this omega is equal to s by j. Now h of s is the transfer function in the s domain. H of s is the transfer function in the s domain. So for this transfer function, for the system to be stable, we find the roots of the characteristic equation. What is the characteristic equation? So in control system engineering, we have already studied about what is the characteristic equation, right? Can anybody tell me what is the characteristic equation? If g of s is the forward path function and h of s is the feedback path function, then what is the characteristic equation? G of s, 1 plus g of s, h of s equal to 0 is the characteristic equation. Right? So, whether you are aware or not, what is the characteristic equation? Are you aware or not? Anybody can respond. If you are not aware, at least I can tell it and proceed further. Aishwarya KN. Anusha R.
Yes, sir.
Are you aware of this characteristic equation or not?
Yes, sir. In control
What is the
systems.
in control system engineering? Okay. Are you aware of it?
Yes, sir.
So what is the characteristic equation? Suppose closed loop transfer function C of s by R of s, okay, is equal to g of s divided by 1 plus g of s is the transfer function. Okay. Then if I equate the denominator to 0, that becomes the characteristic equation. That becomes the characteristic equation. Similarly, h of s is the transfer function. Now, the denominator, if I equate it to 0, I get the characteristic equation. So, you can write the characteristic equation is 1 plus s by j to the power 2n equal to 1 divided by 1 plus s by j whole square or whole to the power of 2n equal to 0 is the correct equation. Therefore, the roots of this equation are nothing but the poles of the system. Isn't it? We get zeros from the numerator, poles from the denominator. Okay? The denominator equated to 0, I get the roots. Those roots are nothing but the poles of the characteristic equation. Okay? Roots of this equation are the poles. Roots of this equation are the poles. So what are the roots then? Root means I should find out the value of s. For what value of s the function is going to become 0. So those values of s are nothing but the roots, or they are nothing but the poles. So that means our aim is to find out the values of s for which this equation is becoming 0. Okay? So anyway, this equation we have made it as 0. Try to find out the value of h, s, which can satisfy this equation. Okay? So what I do now, retain only s by j to the power of n on the left hand side. 1 I will simplify. S by j whole to the power of 2n is equal to minus 1. Therefore, s by j is equal to, I'll remove this power, so it becomes minus 1 to the power of 1 by 2. S by j is equal to minus 1 to the power of 1 by 2. Or s is equal to j transfer j into minus 1 to the power of 1 by 2. S is equal to j into minus 1 to the power of 2. So I have many values of s which can satisfy this equation. Okay? So I have many values of s which can satisfy this equation, and so that finally the value is going to become 0. Okay? So s is given by this equation. I can write sk. Why do I write sk? S is not a single value which can satisfy this equation. There are multiple values of s which can satisfy this equation, for which the value of s is equal to j into minus 1 to the power of 1 by 2n. So let us try to find out what are those values of s for which this equation is satisfied, or in other words, this equation is satisfied. Now we have sk is equal to j into minus 1 to the power of 1 by 2. This equation is written here. J can also be written as e to the power of j into pi by 2. J can also be written as e to the power of j pi by 2. Let us see whether this is true or not. If I consider e power j pi by 2, what is e power j pi by 2? It is cos pi by 2 plus j sin pi by 2. Okay? E power j pi by 2 can also be written as cos of this e power j theta. It is nothing but cos theta plus j sin theta. So that way e power j pi by 2 can be written as cos pi by 2 plus j sin pi by 2. Cos pi by 2 is 0. Sin pi by 2 is 1. So it becomes simply j. Right? Therefore, j can also be written as e to the power of j. Now, similarly, minus 1 if I write. How can I write this minus 1 similar to this? For what value e power something this becomes minus 1? This is true for e power j pi. Is it not? E power j pi can be written as minus 1. Why? E power j pi means what? It is cos pi plus j sin pi. Cos pi is minus 1. Sin pi is 0. 0 into anything is 0. It becomes minus 1. So minus 1 is nothing but e to the power of j pi. And this is true not only for one value of this one e power j pi, this is also true for e power j into pi plus 2 pi, that is p pi. Pi plus 4 pi e power j into pi pi. Is it not? Because suppose if I take e power j into p pi, it can be written as cos of 3 pi plus j sine of 3 pi. Sin pi, sin 2 pi, sin 3 pi, all these values are zeros only. What about cos 3 pi? Cos 3 pi is same as cos pi, that is nothing but minus 1 only. Therefore, even for e power j 5 pi also we get minus 1. Okay? In general, e power j into this values I can write it as 2k plus 1 into pi. This should be an odd value because pi, 3 pi, 5 pi, these are all odd values. So any odd value we can determine using this value 2k plus 1 into pi. Okay? Therefore, Sk, which was given as j into minus 1 to the power of 1 by 2 can now be written as what is j? E power j pi by 2. Okay? And then this minus 1 is e to the power of j 2k plus 1 into pi. This to the power of 1 by 2n. Minus 1 value is this. So minus 1 to the power 1 by 2 and a half. So for this value to the power 1 by 2. Now this is equal to e power j 5 by 2 into. This is like x power m power n. So x power m power n. That is written as x power mn. Right? In the same way, this is like your e power x power y or e power m power n. So it becomes e to the power of j k plus 1 into pi. This is divided by 2. Right? Divided by 2. This is further written as e to the power of j pi by 2 into e to the power of j. Look at this. 2k pi plus pi. 2k pi plus pi divided by. Or this is equal to further e to the power of j pi by 2 into e to the power of this I split into two parts, a plus b by c, can be written as a by c plus b by c. So it's like 2k pi by 2n, 2 gets cancelled, k pi by. The second term is pi by 2n. Okay? Like 2k pi by 2n, which is nothing but k pi by n. And second one is pi by 2. Since we have two terms, for both the terms, the base is common. So I can write it as e to the power of j into pi by 2 plus a pi by n plus pi by 2. Or this is the e power of j theta. I mean, yes, I have sk as a reference, right? Sk is equal to e to the power of j theta square. Sk is equal to Sk is equal to e to the power of j into theta. So the poles are sk is equal to e to the power of j into theta k. So we have sk is equal to e power j theta k, where theta k is equal to this value. I'll write it like a pi by n plus pi by 2n plus pi by k pi by n plus pi by 2n. I'll write this term last pi by n. Okay. So that means I can write down the different values of the poles sk. I can write down the different values of the pole sk. If I substitute k equal to 0, I'll get the first pole. For k equal to 0, s not equal to e power j theta naught. S1 equal to e power j theta 1. I'll substitute k equal to 1. If I take k equal to 2, S2 equal to e power j theta 2, and so on. I can write it. So, first of all, let me select k equal to 0 and let me find out what is the value of theta. What is the value of theta? Okay. So, you write down for theta equal to 0, for k equal to 0, theta not equal to k is 0, 0 into anything is 0 plus pi by 2n. Okay, and again, let us select n value also for n equal to 3%. If I select n is equal to 3, for n equal to 3, when I select k equal to 0, the first term is 0. What about the second term? Pi divided by 2 into 3, that is pi by 6. Plus pi by 6. It's a constant. So, what is this value? If I take LCM, it is 6. This 5 plus 3 pi, or simply this is 4 pi by 6, or simply this is 2 pi by 6. Theta naught is equal to 2 pi. Similarly, for k equal to 1, I get theta 1 is equal to 1 into pi by 3 plus pi by 2n is again pi by 6 and this is pi by 2. This is nothing but 2 pi by 3. I can write it as 2 pi by 3. Because pi by 2n plus pi by 2 already I have calculated. Its value is 2 pi by 3. I can simply add the 2 pi by 3. I can simply add 2 pi by 3 to this 2. Now pi by 3 plus 2 pi by 3 would be now 1. In fact, it is pi by 3 plus 2 pi by 3 means it is 3 pi by 3 or simply it is 1. Now for k equal to 2, theta 2 would be equal to 2 pi by 3 plus again 2 pi by 3, it is 4 pi by 3. Now look at this. The first value is 2 pi by 3. Second value is pi or 3 pi by 3. Next value is 4 pi by 3. So you can imagine what the next value. 2 pi by 3, 3 pi by 3, 4 pi by 3. Next would be 5 pi by 3, 6 pi by 3, like that. So that means for k equal to theta 3 equal to 5 pi by 3. For k equal to 4, it would be 6 pi by 3. 2, 3, 4. So that would be 0. K equal to 2. And then other would be 6 pi by 2. This is nothing but 6 pi by 3 is nothing but 2 pi. Okay? 6 pi by 3 is nothing but 2 pi. And k equal to 5, I get 7 pi by 3. 7 pi by 3. 7 pi by 3 means what? It's like 2 pi plus pi by 3. 2 pi plus pi by 3. And then next value would be 2 pi plus 2 pi by 3, which is same as proportional. The values are going to be repeated. So look at this. First value is 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3, 6 pi by 3 is nothing but 2 pi, 7 pi by 3. 7 pi by 3 means what? 2 pi plus pi by 3. Okay? If I go for the one more value, it would be 2 pi plus 2 pi by 3, which is same as 2 pi by 3. That means from then onwards, these values are going to be repeated. That means for n is equal to 3, we get 6 values of theta or 6 poles I get. For n is equal to 3, I get 6 poles. Okay? Therefore, S naught is equal to 1 angle theta naught is equal to 1 angle 2 pi by 3. S1 is equal to 1 angle theta 1. This is equal to 1 angle pi. S2 is equal to 1 angle theta 2 is equal to 1 angle 4 pi by 3. S3 is equal to 1 angle theta 3, 1 angle 5 pi by 3. And S4 is equal to 1 angle theta 4, 1 angle 2 pi. 1 angle 2 pi means 1 angle 0 only. 1 angle 0. And S5 is equal to 1 angle theta 5. So this is 1 angle, it's like 7 pi by 3. Or 6 equals 1 angle. 1 angle 5. So we will stop here. We'll continue in the tomorrow's class from this points onwards. Okay, you can note out these things, go through these things once, and then tomorrow we'll continue with the same things. And for your test, only that the second module you can do. Okay? Whatever we covered in the second module, that is fast Fourier transform, only those things we can consider. Okay? We'll stop here.